Hey everyone, this is Juan. I'm going over chapter 15 homework, problem number 2. So it says here, up here, a block of mass 2 kilograms hangs from a spring with K constant 18 Newton meters. It is lifted up to a height of Y equals 20 centimeters and dropped from rest. What is the period of the motion? So for spring constant and you're trying to find the period, the fundamental equation we're going to use is T equals 2 pi times the square root of the mass over the spring constant. So the professor was gracious enough to give us the spring constant, which is 18, and the mass was 2. So the period of that is going to equal 2 pi times the square root of 2 kilograms over 18 Newton meters. I should mention that this is 2 kilograms. Yeah, as stated up here. Okay, so this comes out to 2.094 seconds. So part B, after 1.2 seconds, where will the block be? So we're going to use this position equation. X of t equals a cosine angular momentum times the time plus v. So the amplitude is going to be 0.2 meters because it is 20 centimeters. So you convert it, you get 0.2 meters, and that's the total displacement, which is what amplitude is, right? So now we need the angular momentum for a spring. So it's going to be the opposite of what we did up here without the 2 pi. So here it's going to be the constant over the mass all under a square root for a spring, as stated there. So it's going to be the square root of 18 over 2, which equals 3 radians a second. So now we want to evaluate this at 1.2 seconds. I should mention phi is 0 since it's released from its maximum displacement. So the position at 1.2 seconds is equivalent to 0.2 cosine 3 times 1.2. At this time, we get a negative 0.179 meters. This means that it is below the equilibrium. So that's just what the negative means. Keep that in mind. Oops, sorry. And here, how fast will it be going at 1.2 seconds? This one's it's a lot simpler. So the velocity of this, we get from a derivative of the position. So derivative of position will give us the velocity at this certain time, which is negative a sine angular momentum times time. And since phi is a constant and goes to 0, so we're not going to include that here, times w, since chain rule, right? So we just plug in, we know what amplitude is, we know what angular momentum is, and we know what the time is. So negative 0.2 sine times 3 times 1.2 times 3. This, the velocity at 1.2 seconds equals 0.265 meters a second. So that is how you solve this problem. I really hope this helps somebody. Anyway, have a nice night and good luck on finals. Take care.